Good morning everyone and welcome to my YouTube channel. So here today we're going to be looking at electrolytes. So what is an electrolyte? So an electrolyte is a substance that dissolves and is able to conduct electricity. So if a substance is able to dissolve in water, but it does not only need to dissolve but also be able to conduct electricity. So that is what we call an electrolyte. Now, an electrolyte may be a strong electrolyte. So now when we look at the strong electrolyte, this one fully ionizes in water. So this one fully ionizes in water to produce many ions. So now as long as it ionizes in water, if you don't use ionizers, you can use dissociate, which means to say they separate in water. Now it has to be fully separates, or that is dissociates, or ionizes, which is the same term, fully dissociates in water to produce many ions. Therefore, it conducts electricity effectively. The example that we might have under this one is we might look at sodium chloride. Mostly we are looking at group 1 elements and strong acids. The example of a strong electrolyte is sodium chloride. We might also have lithium chloride is also a strong electrolyte. We might also have strong acids. Generally, all strong acids are strong electrolytes. So strong acids such as hydrochloric acid, which is our HCl. We might have another strong acid, which is our sulfuric acid. So these are able to fully dissociate in water to give many ions, thereby carrying a charge. So now I'll further explain why this is very, very important. Even our acid, which we call nitric acid. So now the way it is, if you look at sodium plus chlorine, sodium chloride, when it is dissolved in water, it separates into sodium plus the chlorine. Now it is important for these to separate, because let's say if we are looking at water like that, we have sodium there, we have chlorine there, we have sodium there, we have chlorine like that. The cycle continues like that. Now for charge to be carried, it has to be taken from the positive to a negative. We know that the charge will be moving like that. So it is very, very important for a substance to dissociate. So these fully dissociate to give many ions, thereby conducting a charge. Likewise, even acids behave in such a manner in which we are going to, if you look at this one, we have hydrogen, negative, positive, negative, positive. So these are able to carry a charge. So this is hydrochloric acid, how it looks when it is dissolved in water, and it is able to effectively carry out a charge. So this is what we mean by dissociate or ionizes, meaning to say it returns to its initial ions. Weak electrolytes, on the other hand, these ones are partially dissociate or ionizes in water, and therefore give fewer electrons. Fewer ions. So these ions, when they are fewer, it simply means to say therefore they do not effectively carry a charge. So that's the way it is. So they do not effectively carry a charge. So that is what we refer to as a weak electrolyte. The example that we might have are basically carboxylic acids. So carboxylic acids is an example of weak acids. The carboxylic acids are examples of weak electrolytes. The example that we might have is ethanoic acid. Yes, these dissolve, but they do not effectively dissociate fully into their ion. We also have another acid which we call citric acid. So citric acid is the acid that is found in lemons and oranges. So that is a weak acid which does not fully ionize in water. So the ionization equation for this is, let's take ethanoic acid. We are going to have CH3COOH. So this one is able to become CH3 plus our hydrogen. So this is the splitting. Now this reaction can proceed in both directions. That gives you the idea to say this is a weak electrolyte because of the double arrows. Or you can say this is the characteristic of weak acids. Arrows will go in both directions. It might change back to that. It might ionize and all that. So it gives fewer ions, therefore does not effectively conduct electricity. We might also have weak bases such as ammonia. So ammonia forms a weak base, which is ammonium hydroxide. This one does not fully ionize in water, therefore it gives fewer ions and does not effectively conduct electricity. Then here on the strong electrolytes, we might have strong bases such as sodium hydroxide. So strong bases, e.g. sodium hydroxide. However, there are substances which we are going to be calling non-electrolytes. So non-electrolytes, these are able to dissolve but do not conduct electricity. So now remember, we are looking at substances such as alcohol. We might talk about sugar. Now many people just know these to be non-electrolytes, but for the sake of the exam, you should know more, because sometimes they might ask you to say the examples of non-electrolytes are alcohol and sugar. Mention at least 3. So now the other non-electrolytes that we have is benzene. We also have another non-electrolyte which is urea. We also have another electrolyte which is our chromophores. Benzene, which is mostly used in making many synthetic products such as rubbers and plastics and many other things. Chromophores, these are used in fluorescence microscopy if you do more research on that. We also have urea, which we excrete as mammals, or rather as humans. So these are examples of non-electrolytes. Thank you very much for watching. Hope to see you in the next tutorial. Have a blessed day.